Hello friends, I'm Parwiz and welcome to Python OpenCV or Open Computer Vision course for beginners. So this will be a 3 hours course that we are going to learn about different topics in OpenCV, like reading image, reading MP4 videos, face detection, eye detection, smile detection, line detection, circle detection, morphological transformation, and many more topics on OpenCV. So now first of all, let's just talk about OpenCV and what is OpenCV. So if you see OpenCV.org, now OpenCV, it's open source computer vision library. It's an open source computer vision and machine learning software library. OpenCV was built to provide a common infrastructure for computer vision applications and to accelerate the use of machine perception in the commercial products. Now the library, there's different optimized algorithms for OpenCV library, which includes a comprehensive set of both classic and state-of-the-art computer vision and machine learning algorithms. Now these algorithms can be used to detect and recognize faces, identify objects, classify human actions in video, track camera movements, and different topics. So if you see come down, and it has C++, Python, Java, and MATLAB interfaces, and it supports Windows, Linux, Android, and macOS. Now there are different applications that you can use OpenCV, for example, for read and writing images, reading and writing on videos, detection of faces and its features like eye detection, smile detection, detection of shapes like circle, line, rectangle, modifying image quality and colors, object identification, motion tracking, gesture recognition. So there are different and there are different applications that you can use OpenCV. Now we're using Python programming language, and the first thing we need to install this library OpenCV. So you can see that it has C++, Python, Java, and MATLAB bindings. So for the installation, if you see pypy.org, now it's the latest release. You can just use pip install OpenCV Python and it will be installed. And also there are different other installation process that you can use, and but you can easily install using pip. So now let's just create our example, our first example in OpenCV. Alright guys, in this part we're going to learn that how you can read an image in OpenCV or Open Computer Vision. So before starting our topic, the first thing you need to download some images. Now we're using images from imageprocessingplace.com, so you can just go to there, and you can, after that you need to click on image database, and from there we are going to use this standard test images of Lena. You need to just click on downloads and it will be downloaded. Now after downloading of the images, you need to add the images in your working directory. So I have already added all the images in here in my working directory. Now the first thing I need, I'm going to just import CV2. The first thing I need, I'm going to print the version of my OpenCV, that what version of Open Computer Vision I'm using. So you can simply say print, and in here I'm going to just say OpenCV version, and you can just say cv2.version. And now let me just run this. So now you can see that I'm using OpenCV version 4, and it is version 4. So now we are going to just read an image in OpenCV. So for reading image or for loading the image, first let me just create a Lena image, and the name of my image is so it is lena.tif. So after this, now there's a function or method in OpenCV that you can read. So this is cv2.mread. So the mread is used for reading of the images. Now you need to just give one parameter in here, that is the image name. So in here my image is stored in the image name is stored in the Lena image variable. So I'm going to just say Lena image. Now after reading of the image, you need to show the image on the screen. So for this, there's a function that's called mshow in OpenCV. So we can just say cv2.mshow, and after this you need to now you need to give two parameters for this. The first one is the window name, so it is, for example, image, and the second one is the image itself. So I'm going to just say image. Okay, now if I run this, let me just run this. You'll see that I have a window, but it became disappear. So let me just run this again. A window, but it's disappearing. Now for this we need to add another, so we need to add a wait key for the window. So let me just show you cv2.wait key, and I'm going to pass 0 in here, so that the cv2.wait key is a keyboard binding function. Its argument is the time in milliseconds. Now the function waits specified milliseconds for any keyboard event. If you press any key in that time, the program continues. If 0 is passed, so for example in here we have passed 0, it waits indefinitely for a keystroke. Now also I need to just destroy all the window. I'm going to just say cv2.destroy all windows. If you have multiple windows, you can specify the name of window in here. Now let me just run this. Okay, now you can see that we are receiving our this image Lena.tif, and now you can see that this is our image. Now if I press any key in here, because I have passed 0 in here, for example I'm going to just press P in here, now you can see the window is closed. Also you can give a name to the window. In here we have given, but also you can give a name to the window. For that you can just use for example cv2.namedWindow, and it will be given. So in here I'm going to just say cv2.namedWindow, and in here you need to just give the name of the window, for example image. Now you can see that this is image. Let me just make it image window. So you can see we have two windows, but you need to, it should be the same as cv2.mshow image window. Now you can see that we have image window in here. Also you can give some parameters in here. For example, you can use cv2.window auto size, window auto size. So this is, I think, auto size or the same. And also there's another one that you can use that's called window normal. So window normal. So window normal. Now I'm going to just run this. So now you can see that this is normal window. Like this you can read an image in OpenCV or Open Computer Vision. Okay guys, in this part we're going to learn that how you can render image in Matplotlib. So the first thing you need to install Matplotlib. So you can just use pip install matplotlib, and it will be installed. So after installation of the matplotlib, we need to import CV2, and after that we are going to import from matplotlib .pyplot, we are going to import matplotlib.pyplot as plt. So after this, now we need to add our image, so we are going to use our Lena image, cv2.mread, and in here you need to specify the image name, so it is lena.tif, and we are going to store this image in the Lena image variable. After this, now you can just say plt.mshow, and in here just add your Lena image variable, so Lena image, and at the end you need to show this, so plt.show. Now let me just run this. So now you can see that this is our images. Now if you want to hide the tag values of x-axis and y-axis, you can do that. So now let me just show you. You can just say plt.xtext. We are going to make it empty, and also plt.ytext. So now you can see that we don't have the x and y axis in here. Now in this image we have a problem. We can see that a color difference in our image. It is because OpenCV renders the image in order of GBR. It means GBR means green, blue, and red, the reverse of the usual RGB format. This is the reason the colors get messed up from OpenCV to matplotlib. Now the matplotlib module displays images according to the RGB, or read green blue method. Therefore, in order to correctly render images from OpenCV and matplotlib, what we need to convert the GBR image into RGB. So now let me just show you that how you can convert that. Okay, now in here I'm going to just convert the image from BGR to RGB. So we can just say PLT or in the mshow in here we need to convert that. Let me remove this. So cv2 dot convert color, and we want to convert the Lena image color, and we want to just say color underscore bgr2 RGB. Now let me just run this. So I think we have an error because we have misspelling in here. It's color. Now let me just run this again. Now you can see that we are receiving a different result in here. So now let me just show you the so let me just say plt.mshow. So Lena image. We are going to just see the both images. So the first one is the converted image, and so we are receiving just this. Okay, now let me just comment this. Okay, you can see that this is the first one, messy color, but this is the converted one. and you can see that we are receiving the expected output. In this part, I want to show you that how you can show multiple images in OpenCV using Matplotlib. So sometimes you may need to show two images. For example, if you want to do filtering or blurring the image, alongside with the blurred image, you want to show the original image. So now you can use Matplotlib for this, Matplotlib subplot for doing of these kind of functionalities. So first we need to import CV2, and after that we are going to just import matplotlib.pyplot as PLT. The first thing we need to load or read our images. So we are going to just use our two images, cv2.mread. So the first image is lena.tif. And also we're going to read our second image, cv2.mread, and the second image is for example it is salah.jpg. So I have already these images in my working directory. So after this, now we are going to plot these images. So for this functionality we are going to use subplot. So we are going to just say plt.subplot. Now in here you need to give the arguments. So the first one is the number of rows you need to give, and after that you need to give the number of columns, and also after that you need to give the image position. So like this, the image position is 1. So also you can do like this. So this is in rows and cols, and also this is the position of the image. After that we are going to just say plt.show, mshow, not show, mshow, and in here we need to add our image. So the first image, and after doing this we need to just give a title for this. So plt.title, and the title is, for example, Lena image. So this was for the first image. Now for the second image we are going to do the same process, just we need to bring change to the number of calls, number of columns. So now in here we are going to just use so this is the rows, columns, and also the image position. So it's in the position is 2 or second. So after doing this, now we need to just show this. So mshow, and we are going to show our image 2. After this we need to just give a title for this, and the title is Salah image, and at the end we need to just show the image. So we can say plt.show. So now let me just run this. Also we need to add our wait key, even though we don't need to add, but you can see that this is our image. But the problem is in here you can see that we have the color is different. Now we have a messed up in the colors. Now as I've already mentioned, one of the main problem when you're going to plot two images or one image in Matplotlib, OpenCV uses BGR color. It means blue, green, and red. But Matplotlib uses RGB color system. Now, we need to convert this BGR to RGB color space, that there will not be any messed up in the colors. So for this, now in here, after loading of the image, we need to just convert this image, convert image from RGB to BGR. So we can just say CV so img1 cv2.cvt color. We are going to add our image in here we want to convert, and so we want to convert the color from BGR to RGB, and we need to do the same process for our second image. So I'm going to just say image 2, and this is image 2. Now in here, instead of showing off our original image, we are going to show our converted image. So this is for image 1, and this is for image 2. Now let me just run this, and you will see that we have our original color in here. So now you can see that our two images have their original colors. Now you can see that in here we have labels X text and Y text. So if you want to remove this, you can do this. Now let me just show you. So in here we can just say plt dot, so plt dot X text. Now we need to pass an empty list in here, and also for the plt dot Y text, for this also we need to just do the same for our first image. And now if I run this, you will see that I don't have the X text and Y text. You can see that in here I don't have the X text and Y text. So like this you can work with multiple images in Matplotlib and OpenCV. In this part we are going to learn that how you can write to an image in OpenCV, how you can work with keyboard events in OpenCV, and also how you can convert a TIF image to GPG image. So now let's get started. The first thing I need, I'm going to just import CV2 from OpenCV library. After that, I'm going to just say Lena image. I need to load my image, or I need to read my image. It is lena.tif. So we can show the image. So cv2.imshow, and we can just say Lena image and Lena image. So this is the window name, and this is the image that we want to render. After that, we are going to just create cv2.wait key. Now we are going to check that if user press escape key, we are going to close the window. In the other case, if the user press S key, we are going to save the image. So right now you can see it's GIF image, but we are going to save the copy of this image as a GPG. So we can just say fk is 27, so it's escape key. We are going to destroy all windows, so destroy all windows. And in elif case, so if our k is or s, it means that the user is pressing S key. In that case, we are going to write our image, or we are going to convert our TIF to the GPG image. So we can just say cv2.mwrite, and you can use the mwrite function in here, mwrite. So the first one is the name of the new image. So I'm going to just say new image.gpg, and the converted image, that's Lena image. And at the end we need to just destroy the all window. So cv2.destroy all windows. So it's simple. First we are going to just get the wait key, and after that we are going to check that if the user press skip key, we are going to destroy our window. In other case, if the user press S key, we are going to save our this TIF image to GPG image. So we are going to create a new copy of this lena.tif at name of new image.gpg. Now let's just check this. Okay, so this is our image. If I press escape key, now the window is closed. Now I'm going to press S key. So in the first, it will save the image at name of new image.jpg, and after that the window will be closed. So let me just click S key, and now let me check my directory. So I have at name of new image dot, yeah, you can see that I have this image and the version is .jpg. So let me just show you, let me change this to second image, second img, and if I press S key, and in here I should see the, yeah, you can see that I'm receiving second image in here. So like this you can work with the writing of the images in Open Computer Vision or OpenCV. In this part we're going to learn that how you can draw different shapes in OpenCV. So using OpenCV you can draw different shapes like line, rectangles, circles, or ellipses and texts. So now let's just create our drawing example. We're going to start from drawing a simple line. So the first thing we need from NumPy, so we are going to import NumPy as np, and also we are going to just import our CV2. I'm going to create a method in here and I'm going to call it drawing shapes. So we're going to draw shapes in a empty or black image. So for this we're going to just create a black image and we are going to use our NumPy, so np dot zeros. So you need to give the size, so 512 and 3, and also we are going to just use np.uint8. So after creating of the empty create black image, so after creating of the image, now we are going to draw our diagonal red line with thickness of for example 4 pixel. So let me just say drawing line. So we can just use cv2.line. Now after this you need to specify that where you want to draw this line. So we're going to draw this line on our image, empty image. After that you need to specify the first point, so the first point is 0 and 0, and after that we need to add the second point, so the second point is 512. After this you need to give the color. So as I have already mentioned that OpenCV is BGR, not RGB. So for example 0, 0 to 55, so it's BGR. So the first one is blue, this is green, and this is red. So it means that we will receive a red color line, and this is the thickness, so I'm going to just give it 4. So now after this we are going to just show this image. So let me just do it in here, so cv2.mShow, and in here I'm going to just, for example, call it drawing shapes img, cv2.weight_key. Also we are going to destroy all windows, so destroy all windows. Let me just call my function in here, so it's draw shapes. So it's just a simple code, it's just for drawing offline. We have imported our library NumPy and also CV2. We have created a black or empty image from NumPy, and after that we are going to draw our line. You can use line function or method for this, cv2.line. So first we need to specify that where we want to draw this line. We want to draw this line on the image. After that you need to specify the first point and also the second point and also the color. so the color is BGR. It means that we are going to create a red color line, and this is the thickness of the line. So now let me just run this. Okay, now you can see that we are receiving a red line. This is the line, and the thickness is 4. For now, if I change the color, for example, I can give it 255. So also I want to change the thickness to 8. Now it means that I'm receiving a blue color line in here. You can see that it's a blue color line. So this was line. Now let's draw a rectangle. Drawing a rectangle. Okay, now for this we can use cv2.rectangle. We want to draw a rectangle on the image, and you need to give the point. So basically it's we need to give the top left corner point and also bottom right corner. So point 1 you need to give in here. So I'm going to give it 384 and also 0. The second is 510 and also 128. After that you can give the color. So for example, I want it should be a blue color or a green color, so 2550. Also you need to give the thickness, so I want to give it 6, or we can give it 7 for example. Now it's just simple code, and now I'm going to run this. Okay, now you can see that we are receiving a green rectangle in here. Also you can draw a circle. Drawing circle. So for this we are going to use cv2.circle. Now for the circle, the first one is we need to give our image. So we want to draw the circle in our image. After that you need to give the center coordinates. So for this I'm going to use 447 and also 63. So this is the center coordinates. After that you need to give the radius. So I'm going to give it 63, and you need to give the color. For the color, for example, 00255, red color circle I want, and also you need to give the thickness. So by default you can see it's none. I'm going to give it 2. So you can see we have a circle. Now in this code, the circle, we want to specify where we want to draw the circle on our image, and this is the center coordinates, and this is the radius, and also color and thickness. Now you can see that our this is not filled. Now if you want to fill this with the color, you can give it -1. So you can see now we have like this circle. Also you can do this with the rectangle. I want to just give it -1. So now you can see that we have this kind of rectangle. Okay, now we are going to draw our ellipse. Now for this we will need some more codes and some more positions. So ellipse. So you can use cv2.ellipse for drawing of the ellipse. Now, so the first one is the image. We want to draw our ellipse in the image, and after that we need to specify the center coordinates. It means the x position, the x location, and also the y location. So for this I'm going to give it 256 and also 256, like this. After doing this we need to give the axis length. So it will be the major and minor axis length for the ellipse. So for this I'm going to give it 100 and also 50. Now we need to give the angle, so for this I'm going to use 0. After this, that we need to give the start angle. I'm going to give it 0. Also the end angle. Now for that I want to give it 180. Now you can specify the color in here. 0 to 55 and 0. So I want a green ellipse. And now this is the thickness. So you can give it, for example, 4. So now let me just describe this code. So you can use, for drawing ellipse, you can use ellipse. Now first you need to specify that where you want to draw this ellipse. I want to draw this ellipse in my image. After that you need to add your center coordinates, the x and y locations, and after that the axis length, the major and also minor axis length. This is the angle, and this is the start angle. This is the end angle of the ellipse. Color, we want a green color, and this is the thickness. Now you can see that we are receiving this is our ellipse. Now if you change this to -1, you can see that now we are receiving a nice ellipse in here. So this was drawing of ellipse. Now also you can draw text. Now let me just show you drawing text. So first we need to create a font, cv2 dot. There are different kind of font, but we are using the Hershey underscore simplex font. And now we can just use cv2 dot put text. So the first one is where we want to draw this text. We want to just draw it in our image. Now you need to give the text. For example, I want it should be OpenCV Tutorials, and this is the x and y position, 10 and also 400, and this is the type of font that we have already created. This is the font scale. Now it should be the bigness of the font. For right now I'm going to use 1, and this is the color. So I want a white color, 255, 255, 255. Also you can specify the thickness, for example 4, like this. Now let me just run this. Now you can see that we are receiving OpenCV Tutorials in here. Now this is the font scaleness. If I change this to 3, you will see that I am receiving a big font OpenCV like this. So like this you can work with the drawing shapes in OpenCV. Alright guys, in this part we're going to learn that how you can handle mouse clicks in OpenCV. For example, left mouse button or right mouse button. So now first let me import CV2, and also I'm going to import numpy as in P. So the first thing we are going to just check our mouse buttons in OpenCV. So let me just say for I in dir CV2 if event in I, and now we can just print our I in here. Now if I print this, so in here you can see that we are receiving different mouse buttons, even flag alt key, flag left button, L button, so L button double click, L button down, L button up. So you can see that there are different mouse event options that you can use in OpenCV. So now we are going to draw a rectangle using our mouse button. So the first thing we need, let me just first create my window name in here. I'm going to just call it drawing shapes by mouse. And first we need to create an empty image in here, so window name, so empty image, np dot zeros. So we need to just give the shape, so 512 and also 512, 3, and this is the data type, np.uint 8. So after this we need to just say cv2.named window, and we are going to add our window name in here. After this we are going to just create a method. I'm going to just call it draw shapes. It takes event as a parameter, x and y, and also we are going to just give flags in here with the params. Now we're going to check if our event is cv2 dot event underscore l button dbl click. So if this is the case, we are going to draw cv2 dot rectangle. And so the first thing, we want to draw a rectangle on the image, and in here you need to give the point positions. We are going to just use x and y. After that you need to give the point 2, or we can call it, it's the width and height of the rectangle, so 200. A color that we want to give 255 00, and also the thickness, so I'm going to just give it 7. And now we need to just set our mouse click, so we can say cv2.set mouse callback, window name, and this is our draw shapes. So after doing this, we are going to create a main method in here. And the main method, I'm going to just create a while, so I'm going to loop, so while it's true, I want to show the image, my window, and also the image. And if cv2 dot wait key it is escape key, we are going to just break. And also we are going to destroy, so cv2 dot destroy all windows. So now we need to call this main function or method in here, f underscore name. We are going to call our main method in here. Now this is our code. Let me just run this. Module numpy has no attribute u. We have error in here. Okay, so the error is in here. It is u ain't 8. Now let me just run this again. So now if I double click, you can see that I'm receiving like this Okay, now let's just do this for the circle. Now, so in here, so we can just let me just comment this. and we can say cv2 dot circle. We want to draw this in our image, and this is the x and y. We need to give the x and y, this is the center coordinates, and for the radius I'm going to just give it 60. This is the color, 0 0 255. It's a red color, and also -1 the thickness. Okay, now if I double click, you can see that I'm receiving a circle in here. So like this you can work with mouse clicks in OpenCV. In this part we're going to learn that how you can create a color track bar in OpenCV. So this example is taken from OpenCV documentation. So the first thing we need, we are going to just import CV2, and after that we are going to just import numpy as in p. So first we're going to just create, so this is a method, an empty method that we're going to just pause this. So after that we need to just also we need to give a parameter of x. We need to create a black image in here. We can just say img in p dot zeros, and here you need to just give the size, so 300 and 512 and also 3, and this is the data type, that np.u int 8. So after creating of this we are going to just give a name for the window, so named window, and I'm going to just call it image. Now we need to create track bars for the color change. So when we change the track bar, we are going to change the color. So for this there's a function of the create track bar in OpenCV that you can use, and in here you need to give the color. So first one is the track bar name, and also the color name, or we can say after that the window name, so it is image, and also we need to give the value 0 to 255. And also we need to give on change. So on change, if you remember, we have created this method and we don't need to add any codes in here. It's just we need an empty method in here. So now we need to just do this cv2.create track bar. This is the track bar name g. This is the window name, and this is the color, so 0 to 55, and also this is the method that we are going to give nothing. Let me just copy this and paste it in here. So RGB, this is B, image 0 to 255, and this is nothing. So after creating of the track bars for the color change, now also we need to just create on-off switch for the track bar functionality. For example, if this if it was off, we don't want to change the color by using the track bar, by changing the track bar. Now if it was on, we want to change the color by using the track bar. So for this we are going to just say switch and 0 off and on. Now we are going to just create a track bar for this. So cv2 dot create track bar, and we need to add this is in here, and also the image, and the range 0 and 1 it should be. So I think 0 is off and 1 is on. And also we're going to just say nothing in here. And now we're going to just say while it's true, we are going to just say cv2.imshow, and in here you need to give the image name or the window name and also the image, and k cv2.wait key, and we're going to change if k is if we press the skip key, we are going to just break our window, and in the else case we need to get the current position of the trackbars, of the 4 trackbars. So we're going to just say r cv2 dot, you can use get trackbar pose and the trackbar name and also the window name. Let me just copy this. So this is for RG, B, and also this is for the last one, for the switch. We're going to just call it S, and in here we need to give this switch in here. So after this, now we need to just check our this switch trackbar that we have created. So if SS 0, now we are going to just say image 0. So if our trackbar is off, we are going to just say image to 0, and in the else case we are going to so this is not, we're going to locate our image for the BGR, and after this we need to just destroy our window. We can just say cv2.destroy all windows, and now let me just run this. Okay, now you can see that this is our trackbar. Right now it is off. If I change this trackbars, you can see that the color of this black image is not changing. Now if I make this on, you can see that one is on, and now you can change the color of the trackbar. So this was in here that we have checked. If it's off, we are going to do this. If it is on, in the else case, if it was not off, we are going to change the black image color to the BGR. So you can see we can do like this. Now if I bring this to off or 0, we cannot bring change to this image. If I bring this again to on, we can change this like this. In this part, we're going to learn that how you can do arithmetic operations on images in OpenCV. So using arithmetic operations, we can apply operations like addition, subtraction, bitwise operations. Now, there are 3 ways that you can do in OpenCV. So the first way is that you can do it manually. The second way is that you can use functions from OpenCV for doing of these kind of functionalities, and the third way is also that you can add weight for the image. So in this part or in this video, we're going to just do manually, and also we will use functions from OpenCV. So first of all, I need to import CV2, and after that I need to just read image. So I'm going to read 2 images. So cv2.imread. So this is my first image. It's Lena underscore color underscore 512.tif. So this is my first image, and also I have image 2, cv2.imread, and this is woman.tif. So now manually you can, for example, you can just say add img1 plus img2. So we're going to add two images, and so now let me just show this as cv2.mshow, and this is addition add. Now we can just say cv2.waitKey 0 and cv2.destroy all windows. Now let me run this and you'll see the result. So you can see that we are receiving poorly result. Now let's just do this with the subtraction. So for example, let me just subtract. We can just say image 1 minus image 2, and we need to show this cv2.mshow, and this is subtraction. And now let me just run this. Okay, so you can see that we have added and also we have subtracted the images, but the result is poorly result. Now there is a function in OpenCV for subtracting and also adding, and let's just check these functions or methods. Okay, now so let me just say adding manually, and now we are going to do this adding via OpenCV methods. Okay, now there's add method in OpenCV that that's used for adding two images. Let me just say add two, and we can just use cv2.add, and we need to add our two images in here, image 1 and image 2. Now let me just show this. So cv2.mshow, and let me call it add2, and this is add2. Now you can see that this is our add2, and you can see the result that we are receiving a very good result for this. If you compare this with the manual adding, this was, now this is a very good result. Also you can do subtraction, so we can just say subtract 2, and you can use cv2.subtract, and we need to add our two images, image 1 minus image, image 1 and image 2. And now we need to show this cv2.mshow, and this is sub2 subtract 2. And you can see that in subtraction also we are receiving a good result. So like this you can add and subtract images in OpenCV. So now subtracting means that we are going to subtract the matrix or the pixels of these images, or we can add the pixels of these images together. In this part we're going to learn about image blending in OpenCV or Open Computer Vision. So image blending is also a type of image addition, but with image blending we can add different weights to the image. So now first we need to import CV2, and after that we are going to read our two image. So image 1, cv2.mRead, and then here we need to add our image name, so it is Lena color .tif, and the second image is cv2.mRead, and this is woman.tif. So now for blending images, there is a function called cv2.addWeighted. So for this we are going to just create a result, cv2.addWeighted. Now in here the first thing we need to, so it's misspelling, add weighted. Now the first we need to add our image, so this is our first image or first source. The second one is that we need to add the alpha value, so it is 0.7, and after that we need to add our second image in here, so image 2, and now we need to add our beta value in here, 0.3, and the last one is the gamma, and for that I'm going to just add 0. Now we can say cv2.mShow and result, so I'm going to name it result. So cv2.weight key, and now let's just run this. Okay, now you can see that we have successfully blended the images and we are receiving a good result. Now you can change this. For example, you can do 0.4, 0.6, and you can see that we are receiving a different result. So like this you can work with image blending in OpenCV. Alright guys, in this part we're going to talk about color spaces in OpenCV. So there are more than 150 color space conversion methods that are available in OpenCV. But we're going to look into some of them that are most widely used. So now first I'm going to import CV2, and after this now we need to load our image. So cv2.mRead, and I'm going to use lena.tif. So after that, so the first one is that we are going to convert our BGR color to gray. So by default, as I've already mentioned, that OpenCV uses BGR, blue, green, red. Now we are going to do conversion from BGR to gray. So we can just say BGR gray. So we can use CVT or convert color in OpenCV. So convert color, and in here you need to add your image, and after that you need to add the conversion type. So it is color. So you can see that they are different, and we are going to use BGR to gray. And now let me just show this. So cv2.mShow, and it is BGR to gray. cv2.weight key. Also, if you want, you can destroy all window. So cv2.destroy all windows, and run this. Okay, you can see that now our color, the color is converted to BGR, and it is from BGR to gray, and it's a gray color image. Also, you can let me just show the original image. So show original image. Okay, now after this we are going to convert our color, our BGR colors to HSV color. So BGR HSV, and we're going to use cv2 dot convert color, and we want to convert our image 1 to cv2 dot color underscore BGR HSV to HSV. And now we can show this. So cv2 dot show, and this is BGR to HSV. And now let me run this. Okay, this is our original image, and this is converted from BGR to gray, and this is converted from BGR to HSV. So now let's just use another one that is lap color. So we are going to just say bright lap and cv2 dot convert color image 1, and this is color underscore BGR to lap. And now we can show our image, and it is BGR to lap. And it's bright lap. Now let me run this. Okay, now you can see that this is BGR to lap, and we have this is our original image, BGR to HSV, this is BGR to lap, and this is BGR to gray. So like this you can do conversion on color spaces in OpenCV. In this part we're going to learn about bitwise operations in OpenCV. So bitwise operations include AND, OR, NOT, and XOR operations. So these operations are very useful when we want to extract any part of the image. So now let's create our example. The first thing we need, we are going to import cv2, and after that I'm going to import numpy as in p. So first we're going to create two images, empty images. So np dot zeros, and we are going to just give it 300 by 300, and the data type is uint8. So now we're going to create a rectangle. So rectangle, and we want to add our rectangle in the image 1, and also we need to give the width and height of the rectangle, and this is the color 255. So this is not the color, this is 250, and this is the color, so 255, and this is the thickness, so I'm going to give it -1, and we can show this. So cv2 dot show image 1 and image 1. Now let's create our image 2. So image, let me just copy this from here, and we are going to bring changes. So this is our image 2, and 300, and this is the data type is uint. And in here we are going to in this image we are going to add a circle. So first we need to add our image 2 in here. After that we need to add the center coordinates, 150, 150, also radius 90, the color is 255, and the thickness is -1. And we can show this, so show. This is image 2 and image 2. So after doing this, first we're going to do our AND. So I'm going to call it AND bitwise. So first let me just cv2 dot weight key 0 and cv2 dot destroy all windows, and let me run this. Okay, now you can see that we have this is circle and this is rectangle. First we are going to do AND bitwise, and we can just use cv2 dot bitwise AND from OpenCV. So in here we need to add our 2 images. So first one is image 1 and the second one is image 2. Now we can show this, so cv2 dot show bitwise AND. Now let's just run this. Okay, now you can see that this is our bitwise AND for the 2 images. We can do OR bitwise, so OR bitwise cv2 dot bitwise OR. So in here we need to add our 2 images, image 1 and also image 2. We can show the image, so show, and this is bitwise OR. Now let me run this. You can see this is our bitwise AND and this is our 2. Now this is the bitwise OR. Okay, another one is XOR. This is the last one that we are going to do. So XOR bitwise cv2 dot bitwise XOR, and in here we need to add our image 1 and also image 2, and you need to just show this, cv2 dot show bitwise XOR. Now let's run this, and you can see that this is our bitwise XOR. Also we have bitwise NOT, so let me just do that also, bitwise cv2 dot bitwise NOT. We're going to add our image 1 and also image 2, and we can just show this, cv2 dot show bitwise NOT, and let me just run this. So now you can see that this is our bitwise NOT. Alright guys, in this part we're going to talk about image rotation in OpenCV. So we can rotate an image in OpenCV using rotate function. Now there are 3 types of rotations in OpenCV that you can use. We have rotate 90 clockwise, rotate 90-degree counterclockwise, and also rotate 180 degree. So So now let's just create the example. First we are going to import CV2, and after that we are going to read our image. So cv2.mread. We are going to use lena.tif. So after reading of the image, first we are going to create the example of rotate 90 degree clockwise. So img rotate 90 clockwise, and as I have already mentioned that you can use rotate function of OpenCV. So rotate, and you can see that we need to give a source. It means the source of image, and this is img, and after that we have the rotate code. Now it is the cv2 dot now we are going to use rotate 90 clockwise. So rotate underscore 90 underscore clockwise, and the last one is the destination. So because we are not going to output this image, we are going to just show this, and now you can just say cv2 dot mshow, and we can say image 90 clockwise, and we can add this in here. So it's smaller cv2. Now okay, so we need to just say cv2 dot wait key, and now let me just run this. So you can see that it is 90 degree clockwise image, like this. Also so you can also, if you want to destroy the window, you can just do cv2 dot destroy all windows. Okay, now the second example is it is the 90 degree rotation, but it's counterclockwise. So I'm going to create img rotate 90 counterclockwise, and we can just say cv2 dot rotate. Now the first one, we need to give our source of image, and after that the rotate code. So it is cv2 dot rotate underscore 90 underscore counterclockwise. So clockwise. Now we need to just show our image. So cv2 dot mshow, and we need to give the title for the window. So image 90 counterclockwise, and also you need to add your counterclockwise image variable in here. So now let's just run this. So now you can see that it is the clockwise, but now it is the counterclockwise. Also another type is that you can use, that is rotate 180 degree. So now let's just create in here image rotate 180, and we can just say cv2 dot rotate, and we need to add our image in here. After that you need to add the rotate code. So it is cv2 dot rotate underscore 180, and we can simply show our image in here, image rotate 180. Now let's run this. So now we can see that it is 180. So like this you can work with the rotation in OpenCV. In this part we are going to talk about scaling image in OpenCV. So scaling is the resizing of the image, and in OpenCV you can use cv2.resize for scaling or resizing the images. Now if you see the documentation of the OpenCV for scaling, you can see that scaling is just resizing of the image, and OpenCV comes with a function cv.resize. We will use cv2 for this purpose. Now the size of the image can be specified manually, or you can specify the scaling factor. Now there are different interpolation methods are used. Preferable interpolation methods are cv dot enter area for shrinking, and cv dot enter cubic, it's slow, and cv dot enter linear for zooming. Now we will use these interpolations in here. Let's now just create our example. The first thing I'm going to just import cv2, and after that we need to just read our image. So img cv2.mread, and we are going to use lena.tif. So after that we are going to just create image scaled. So cv2.resize, and in here we need to first we need to give our source image, so this is img, and after that we need to give the d size. Because we are not using any d size, we are going to just give it none. So we don't need to give the destination, and after that we need to give the factor x, so fx, I'm going to just use it 1.2, and the factor y, so it is also 1.2, and after that you need to give the interpolation, so interpolation. For the interpolation, I have said that there are different interpolation, so for this we're going to use cv2.enter linear. So if you see the documentation, so cv enter okay, now this is the cv.enter linear is used for all resizing purposes. So we're going to use this. And now let me just show this. So cv2.mshow, and we are going to just say linear interpolation. We need to add our image scaled in here. cv2.wait key, and cv2.destroy all windows. And now let's check this. Okay, so you can see that this is a linear interpolation, and let's just use another one that is cubic interpolation. So let me just say image scaled, or we can say image2 scaled, and cv2.resize. So the first one is our image, the second one is none, and after that we need to add the factor x or fx 1.2 and fy 1.2, and we need to just bring change to the interpolation. So for the interpolation, this time we're going to use cv2.enter cubic. Now if you see for the enter cubic, our CV for shrinking and enter cubic for slow. So now it's let me just show this. cv2.mshow cubic interpolation, and we are going to just add image 2 scaled. So you can see that this is our cubic interpolation, and let's just use another one that is enter area. I'm going to just copy all of them and paste in here. So it's image 3 and img like this. Okay, we are going to just bring change in here, so it is 450 and also 400. Now if you see the documentation, now this enter area this is for shrinking, and the interpolation we are going to just use enter area. Okay, now let's just run this. Okay, now you can see that this image is shrinked, and you can see that it's bigger and it's shrinked like this. Okay, now let's change this to, for example, 700 by 500. So you can see that we are receiving this kind of result. In this part we're going to learn that how you can read EVI videos in OpenCV. So you can read videos from your camera feed, and also you can read the videos from, for example, the videos or MP4 or it is EVI video. Now, and particularly in this video we're going to read an EVI video. So let's just create our example. So we're going to import CV2. After that we are going to just create our cap. So cv2.video capture, and in here you need to give your video name. So it is sample vid.evi. So make sure that you have already added this the video in your working directory. Now if you remember, I have said that you can read videos from your camera feed. Now if you want to read the video from camera feed, you need to just change this to 0. So for the camera, and now if you want there's a file of video that you want to read, for that you need to just write the name of that video in here. So after this, now we're going to just create a while. Now we need to check that if our cap dot is opened. So if it is opened, we are going to read our video frames. So cap dot read. And now we can just say cv2.mshow frame, and now we are going to check that if cv2.wait key, so when we are going to just give delay time to 1. So if it is Q, so if the user press Q, we are going to just break like this. Okay, and in the else case, we don't have any else case, we are going to then we need to just release our capture, and also we can just say cv2.destroy all windows. So it's just a simple code. We are going to, in here we are going to just read our AVI video. Now if I have already said that if you don't want to read any video, you can just if you want to work with your camera feed, you can just add 0 in here. And in here we are going to check that if our capture is opened. If it was opened, we are going to read our captures, our frame captures, and in here we are going to just show our frame, and in here we are going to check if the user press Q, we are going to just break or quit the window. So now let's just run this. So now you can see this is, if I press Q, now you can see it's the window is quitted. Now let me just add another video in here. It's my vid.avi. So now you can see that this is the video. Now if you want to convert your video color to, for example, to gray, you can also do. So before showing, we are going to just convert video color to gray. We can just say gray cv2 dot convert color, and we want to convert the frame color from BGR, so BGR to gray. And now instead of showing frame, we are going to just show grain here. So now we can see that, so now we have a gray color AVI video. Alright guys, in this part we are going to learn that how you can read an MP4 video. So I've already said that you can use an MP4 video, or you can use a camera feed. The same code will be implemented with a camera or MP4 videos. Now let's just create our example in MP4 video. So I'm going to just import CV2, and after that I'm going to just create my capture. So CV2 dot video capture. And in here you need to give your video name, so it's mp4 vid.mp4. so make sure that you have already copied your videos in your working directory. Now if you're going to work with a camera feed, you need to just remove this, and in here you need to just pass 0. Now if you're working with the videos, you can just add the video name in here. And now after this, we are going to just check if our cap if our cap is not open, so if it's false, we are going to just print an error. So error opening mp4 video. And now we are going to so if there was not error, we are going to just say while cap dot is opened, we need to read our frames. We can just say cap dot read, and now we are going to check that if this is true, we are going to show our frames. So cv2.mshow, and now in here you need to add your frame, so frame. Also we're going to check that if the user press, for example, Q key in the keyboard, we are going to close the window or break the window. So if cv2.wait key, so the delay we're going to just give 25, or Q. So if this is the case, we are going to just break. Now in here, in the else case, also we are going to break. And at the end we are going to release our cap, so cap.release, and also we are going to just cv2.destroy all windows. Now you can see that this is my video, so it's an HD video. You can see that this is the video frames, and now you can see this is one of the videos. Import cv2. So like this you can work with the reading of the videos in OpenCV. Okay guys, in this video we're going to learn that how you can write to a video. Now let's just create our example. We are going to just say import CV2, and in here I'm going to just create diff main. So first I'm going to create a name for my window, so it is writing to a video, and now we need to add this name, so named window, and we are going to add our window name in here. After this we need to create our video captures, so cv2 dot video capture, and in here because we are not using any camera feed, we are using just a simple video, and I need to add my vidsample.mp4. so this is the name of my video. I have already added this video in the working directory. Now after this we are going to just create a video output, so video output, and cv2 dot video writer, so we can use video writer for writing to an image or adding changes to an image. Now there are different parameters that you need to give for the video writer. We need to give file name, codec, frame rate, and also resolution. Now we're going to just create these in here. So first we need to give file name, so this is the file name that we are going to do output, so it is out.avi, and also we need to just give the codec in here, so cv2 dot video writer, so video writer, and it is 4cc. so this 4cc means 4 character codec. Now there are different codec that you can use, and here we are going to use xvid, so v I, and also D. I think there are different video codecs that you can use. For example, we have H256 I think, and also we have MPEG, and there are different 6 or 7 or 5 video character codecs. So after creating of the codec we need to create our frame rate, so frame rate, and we are going to just use 29, and also resolution. I'm going to use this resolution, so 640 and 480. Now we need to add these in here. So the first one is the file name, and after that we need to add our codec and our frame rate, and the last one is the resolution. Okay, now we are going to check that if our cap is opened, so is opened. We are going to just say cap, we need to read that, and in the else case we are going to just return false. Now I need to read my video frames in here, so I'm going to just create a while loop, so while read, we can just say cap.read. So also I'm going to just when outputting or saving my video, I'm going to just add a circle in the video, so I want to add that in my frame, and this is the coordinates and also the radius 80, and this is the color 0, 0 and 255, a red color circle, and this is -1 the thickness. So now we need to write, so video output dot write to the frame. We can just now show, so cv2 dot mshow, we are going to just add the window name and also the frame. Also we're going to check that if cv2 dot wait key, so if the user press escape key, we are going to just break the window, and after that we are going to just destroy our cv2.destroy all window, and we need to release the frame, so video output dot release, and also so this is for the video output, and also for the capture we also are going to release that. So this is the code, and now we need to just call our main function in here. Main, we are going to call our main function in here. Okay, now you can see that this is our video, and it's playing. Now after quitting of the video, I should see an out.evi in my working directory. So let me just quit this now, because in here you can see that we have out.avi. So now you can see that we have out.avi in here. Now let me just play this. Okay, now you can see that we have this circle in here, red color, that we have already specified, and this is also the format. So you can see that it's AVI. So the original format is .mp4, but now it's converted to AVI, and you can see that we have this circle in here. In this part we are going to learn about 2D convolution or image filtering in OpenCV. So you can do image filtering using low pass filters, LPF, and also high pass filters, HPF. Now for example, if you want to remove the noises of the image, you can use LPF filter, or if you want to blur an image, also you can use LPF. And using HPF filters, we can find the edges in the images. Now in OpenCV we have a function that's called cv2.filter2d, and you can use that. So if you see the documentation of OpenCV, so 2D convolution or image filtering, so it is as in one-dimensional signals. Images also can be filtered with various low pass filters, LPF, and also high pass filters, HPF. You can see that LPF helps in removing noise, blurring images, etc. And HPF filter helps in finding edges in images. So now let's just create our example. So in this example we are going to use a 5x5 averaging filter kernel. So first we need to import cv2, and after that we are going to import numpy as in p, and okay, we don't need to import. Okay, so we need these imports. So after that we need to just read our image, so cv2.mread, and in here I'm going to just use lena.tif, and now I need to create a kernel in here, so it's 5x5, so np.ones 5x5, and this is the data type, so np.float32, and we need to just divide this by 25. So after that we are going to create a filtered 2D, and cv2.filter filter 2D, and in here the first one is the image that we need to add, and after that we need to add the depth. I'm going to use -1, and also you need to add the kernel in here, so we have 5x5 kernel. And after this we need to just read our image, so cv2.mread, not mread, sorry, it is I've already read the image. We need to just show the image. This is our original image, and we are going to just cv2.mshow filtered. I'm going to just call it filtered, and filtered 2D. Now we need to just use cv2.waitKey and cv2.destroy all windows. So it's just a simple example. We have read our image, and this is our kernel 5x5, and this is our filter 2D function. We need to pass our image, dtyped, and also the kernel, and we have simply showing the original image and also the filtered image. You can see that this is our original image, and you can see the difference. This is our filtered image and it's blurred. So like this you can work with the filter 2D function in OpenCV. Alright guys, in this part we're going to talk about image blurring or image smoothing. So image blurring or image smoothing is used for removing image noises, and it's used for removing high frequency contents like noise and edges. So according to documentation of OpenCV, there are 4 types of blurring techniques in OpenCV that you can use. So let me just bring the documentation. So image blurring, we have averaging, we have Gaussian blurring, we have median blurring, and we have bilateral filtering. So that we are going to just talk about these in this video. So now first we're going to start from average blurring. Now in average blurring, we take the average of all pixels under the kernel area and replace them with the central element with this average. And in OpenCV you can use cv2.blur for these kind of functionalities. Now we are going to import cv2, and we need to just read our image. So imread, so it is lena.tif. Now after that I have said that you can use cv2.blur. So let me just say blurred image, or we can say avg blur, and we can say cv2.blur. So first we need to add our image in here, and after that we need to add the k size or kernel size. So let me first add 5x5. You can change this. Now we need to just show this. So cv2.imshow. First we are going to show our original image, and also we are going to just show our average blur, and okay, cv2.waitKey and cv2.destroy all windows. Now you can see that this is our original image, and you can see that this is our average blurring image. Now you can change, if we change this to 10 by 10, so you can see that we are receiving a different result in here. The second technique for smoothing the image is Gaussian blurring. So in this technique we need to specify width and height of the kernel, which should be positive and odd according to OpenCV documentation. Also we need to add standard deviation in the x and y directions. It means sigma x and sigma y. So for this purpose we can use cv2.Gaussian blur function in OpenCV. So now let's just see the example. First we are going to import cv2, and after that we need to just read our image. So .imread, and it is lena.tif. Now we are going to just create a Gaussian blur, cv2 dot let me just make it correct spelling like this. So Gaussian blur. So the first one is the source, it is our image, and the second one is the kernel size. We are going to just give 5 by 5, and also we are going to just give 0 for the sigma x. We don't need to give any destination. We can just say cv2.mshow. This is our original image, and cv2.mshow Gaussian image, cv2.waitKey, and cv2.destroy all windows. Let me just run this. So you can see that we are receiving this result in here. In this part we're going to learn about median blurring. So median, it's the third techniques for smoothing of the images. So median blurring computes the median of all pixels under the kernel, and the central pixel is replaced with the median value. Now according to OpenCV documentation, it's mostly used for removing salt and paper noises. So if you see the documentation, and this is the function cv.medianblur that you can use, and this is it's telling that this is highly effective against salt and paper noises in an image. So now let's just create our example. So the first thing I need, I'm going to just use import cv2, and now let me just show you that what image I'm going to use. So this is the image that we are going to use. It's Lena, but you can see that we have noises, salt noises in here. So after this we are going to just say cv2.mread, and it is lena_salt.png. After that we are going to just create median, so we need to use cv2.median blur. So first we need to just give our image in here, and after that we need to give the kernel size 5, and the destination is none. Now we can show this, so cv2.mshow, so our original image, and also we are going to show the median blur, so cv2.mshow median blur, cv2.waitKey, and destroy all the windows. So destroy all windows. Now let's just run this. Okay, now you can see that this is the median blur, and this is our original image. So you can see that how this image is smooth, and you can see that the original image is not good. So like this you can work with the median blur in OpenCV. Alright guys, in this part we are going to talk about bilateral filter. So it's the last one. A bilateral filter is non-linear age preserving and noise reducing smoothing filter. Now the intensity value at each pixel in an image is replaced by a weighted average of intensity values from nearby pixels. So if you see the documentation of bilateral filtering, you can see that you can use this bilateral filter is highly effective in noise removal while keeping edges sharp, but the operation is slower compared to other filters. We have already saw that a Gaussian filter takes the neighborhood around the pixel and finds its Gaussian weighted average. So now let's just create an example. We are going to use this image face, and we are going to smooth this image. So the first thing we need to import cv2, and also I'm going to import matplotlib.py plot as plt. So the first thing is that we need to read our image, cv2.imread, and our image name is so image face dot it is gpg, yeah. And after this we are going to just create our bilateral filter, so blur. Now let me just first add the syntax for this filtering. Let me just bilateral filter. Okay, now you can see that this in here first we need to give the source. So this is the source, this is the destination. It is the destination or output image. This is D. It's a variable of type integer representing the diameter of the pixel in the neighborhood. And this is the sigma color. It's a variable of the type integer representing the filter sigma in the colors in the color space. And also we have sigma space, so a variable of the type integer representing the filter of the sigma in the coordinate space. And also you can give a border type. So now let's just use this. So cv2 dot bilateral filter. So we need to add our image in here, and after that, so I think we have let me just copy this and add this in here. So first we need to add the source image, and also we need to add the D or diameter. So it is we're going to give 13. You can change this. So first let me just give 10, or for example 8, and this is the sigma color 75, and also sigma space 75. And now we need to just show this. So because we're using matplotlib, so first I'm going to just create a subplot, and now we can just say plt.imshow. We are going to add our original image in here, and also you can give a plt.title. So this is original image, and also we are going to just hide the x text, and also plt.ytext. Let me just copy this. So this time we are going to use our filter, and this is and we don't want the x text and y text in here. And at the end we can just use cv2.wait key 0 and cv2.destroy all windows. Now let me just run this. We have an error in here, so warning message. Let me just check that where's the problem. So I think it's because we're using the same subplot. Let me just change this because we have copied that. And now we have another problem in here. Okay guys, at the end sorry, we need to show this, so plt.show. Now let me just run this. Now you can see this is our original image, and this is our bilateral image. Now you can see we are receiving now first we need to just because I've already said that when you're going to work with the matplotlib, because matplotlib uses RGB color space, Now OpenCV uses BGR. Now we need to convert BGR to RGB, and we will see the result, that how it will look. So for this in here, I'm going to just create CVT. First I'm going to just use for my original, convert my original image, cv2.convertcolor, and we are going to add our image, and cv2.color BGR to RGB, and I'm going to copy this and paste it in here. So this time we are going to just use for blur, and okay, now instead of showing our in here, we need to just use this, and another subplot we are going to use this. Now we are going to run this. Okay, now you can see that we have converted the colors to RGB. It's good, but we need to just change this to receive good results. So if I change this to 13, and if I run this, so now you can see that we have a nice and smoothing image in here, and the result is very good than this. You can see the result in here. Alright guys, in this part we're going to talk about face detection with Haar Cascade in OpenCV. So OpenCV comes with a trainer as well as detector. If you want to train your own classifier for any object like car, planes, etc., so you can use OpenCV to create one, but in this video we're going to use from trained models that are existing. So you can see this is the GitHub link, and you can see that there are different classifiers. We have for eye, 3 eyeglasses, frontal face alt, and full body, and there are different classifiers, pre-trained classifiers that you can use these models. Now the first thing I need, I'm going to just import CV2. So after importing CV2, I need to read my image, so cv2.imRead, and my image name is lena.gif. So after reading of my image, now I need to load my classifier. So I have already downloaded. So for this face detection, we are going to use frontal face. So we are going to use this classifier, or frontal face default classifier. Yeah. We are going to use this classifier, frontal face default Haar Cascade frontal face default .xml. So you need to just download this and add this in your working directory, as I have already added. So we are going to just use face cascade. I'm going to just use, and in here we need to just use cascade classifier. So cv2.cascade classifier. After adding our okay, now in here we need to pass the file name. So now let me just bring, you can see that I'm using this frontal face, and I need to just copy this name, so Control C, and now I need to add the file name in here. So after loading of this, now we need to use detect multiscale from this cascade classifier. So we can just use face cascade dot detect multiscale, and so this detect multiscale function is used for detecting faces. Now you need to add some parameters in here. So the first one is the image source that we want to do. So this is the image that we are going to do face detection on this image. That's lena.gif. And after that we need to add the scale factor. Now the scale factor parameter is used for specifying how much the image size is reduced at each image scale. So for the scale factor I'm going to just use 1.1. and after that you need to add the main neighbors. Now the main neighbor parameter is specifying how many neighbors each candidate rectangle should have to retain it. Now this parameter will affect the quality of the detected faces. Now if you give higher value, for example in here I'm going to give main neighbors to 5. So now if you give higher values like 10, 12, 13, now the results will be a fewer detection. But 5, 3 up to 6, up to 5, it's a good value to detect faces. Now after adding this, now let me just use print face detected img. Now let me just first run this, that it's detecting face for me or not. So okay, so we need to just we don't need to use image, we are going to use the length of faces. So sorry. Now I'm going to run this again. Okay, now face detected 1. Now let's check our lena.tif image. So you can see that in the lena.tif I have just one face in here. Now let's just draw a rectangle on the face. So in here I'm going to just say for x, y, so these are the positions. Width wh is width and height, and faces I'm going to just say cv2.rectangle, and I want to draw a rectangle on my image. And so we need to give the points, for example 0.1 x, y, and also we need to give the 0.2, so x plus width and y plus height or h. And after that we need to give the color of the rectangle that we want to draw. So I want a green rectangle, and at the end we need to add the thickness 5. So now we need to just show this. Let me just cv2.mshow, and so face detection, we need to pass our image in here, and after that we need to just say cv2.waitKey, and also cv2.destroy all windows. Okay, now let me just run this. We have indentation error. Okay, now let me just run this again. cv2 has no attribute waitKey. We have another error. It is waitKey. Yeah, now you can see that face detected 1, and you can see that we have a rectangle on the face. So like this you can do face detection using hard-cascade classifier in OpenCV. Alright guys, in this part we are going to learn about eye detection using hard-cascade classifier. So the first thing you need to download the classifier from the GitHub, and for this we are going to use the hard-cascade_eye because we are going to do eye detection. And the image that I'm using, that is lena.tif, so we are going to eye detection on this. So first of all we need to just import cv2, and after that we are going to read our image, so cv2.mread, and add your image name, so it's lino.tif. After that, we need to load our cascade classifier, and it is cv2.cascade classifier. Now in here you need to add the name of your this cascade classifier. It's cascade_eye.xml. Make sure that you have already added this file in your working directory. Now if you see in my project working directory, I have cascade_eye.xml. Now I need to just get the name of this classifier. I want to copy this and paste in here. So after loading of the classifier, now we need to use detect multiscale function. Now detect multiscale function is used for detecting of faces or eyes or smiles. So now in here, because we are using eye, so for this we can just say eyes and eye cascade dot detect multiscale. Now we need to add some arguments or parameters in here. So the first one is the image, the source image in here that we know we need to add, and after that we need to add the scale factor. Now as I have already mentioned, that the scale factor is used to specify that how much image size is reduced at each image scaling. For this we are going to add the scale factor to 1.1. And after this, the another one is we need to add the main neighbors. So we need to just say main neighbors, and I'm going to add 5 in here. Now this is used for specifying that how many neighbors each rectangle should have to retain it, and this parameter will affect the quality of detected faces. Now higher value results in fewer detection but with higher quality. 3 up to 5 or 6 or 7 is a good value for it. So after adding this, now we need to just because we want to draw rectangle in the eyes, so now we need to just create a for loop. So we can just say for ex and ey, ew and eh and eyes. We are going to just say cv2.rectangle, and here we need to add our image that we want to draw rectangle on that image, and we need to add the point 1. So it means the width and height, and so we can just say, so it's the point, the x and the y position, so it is ex and also ey. And after that we need to give the width and height of the rectangle, or we can say the point 2, so it is ex plus ew and also ey plus eh. And at the end, this is the color, that what color you want for the rectangle. I'm going to use 25500. So I'm going to use a blue, so because it's BGR, so this became blue. And for the thickness, I'm going to give it 6. So now after this, we need to show our image. So cv2.imshow and eye detection. You need to pass your image in here. And also we can just say cv2.readKey and cv2.destroy all windows. Now let me just run this. Sorry, we have a name error in here. It's because cv2 okay, now you can see that these are the 2 eyes that we have in here. Okay, now let me just use another image and see the results. So this time I'm going to use salah.jpg, and So you can see that in this image we have our two eyes in here, but the hard cascade classifier also detect this also as an eye. Now I've already said that you can change the main neighbor for this. For example, if I change this to 7 from 5, let me just see this, the same result. But if I change this to 8, the main neighbors, and let me just run this again, so you can see that now I'm receiving the good result in here. So these are the two eyes. So like this you can work with eye detection and with hard cascade in OpenCV. In this video we're going to learn about smile detection in OpenCV. So for the smile detection, the first thing you need to download the classifier, so from the GitHub. So now this is the hard cascade smile. You need to download this, and after that add this in your working directory. So after downloading, now we need to start our coding. First we need to import CV2. After that we need to just load the image or read the image, mread, and in here you need to add your image name. So my image name is this is the image name that I have added. Now we need to load our smile cascade classifier. So for this for that you can use cascade classifier from OpenCV. So smile cascade, and in here we need to just add cascade classifier. So the first thing, so in here you need to add the name of the classifier. If you see, I have added the classifier in here, and I'm going to just copy the name and paste this in here. So after loading of the hard cascade classifier, now we need to use the detect multiscale for detecting of the smiles in an image. So we're going to just create smiles and smile cascade dot detect multiscale, and the first thing you need to pass your image in here, and after that you need to add your scale factor. So scale factor, and okay, so for the scale factor we are going to add 1.8 in here, and also you need to add the main neighbors. So main neighbors, and I'm going to add 20 in here. So let me just check this, that's how it's working. And now we're going to just create for SX and SY, SW and SH in smiles. We need to just create a rectangle in our image. So SX and SY, so this is the point 1. So after that we need to add our point 2, so SX plus SW. Also we need to just add SY plus SH. This is the color of rectangle, so I want a red color rectangle, and this is the thickness. Now we can just say cv2 dot weight key and cv2 dot destroy all windows. Okay, now let me just check the result. We need to show this. I have already forgot to show this. So cv2.mshow smile detection, and we are going to add our image in here. Okay, now you can see that this is the result for the smile detection. Now let me change this to, for example, 10 or 20 years, I think more. If your image has more than, for example, 2 or 3 smiles or faces, then you can use this number. Let me just change this to 7, and so no, you can see that I'm not receiving any good result for this, and by this reason I need to change this to 15, and okay, now 15 is good. So you can see that this is our cascade classifier. So the result may be poorly, but you can see that we have detected the smile. In this part, we're going to talk about morphological transformation in OpenCV. So if you see the documentation of OpenCV, morphological transformations are some simple operations based on the image shape. It's normally performed on binary images, and it needs 2 inputs. One is our original image, and second is called structuring element or kernel, which decides the nature of operation. 2 basic morphological operators are erosion and also dilation, and we are going to use this image from OpenCV documentation. Also, the first one we are going to talk is erosion. Now, the basic idea of erosion is just like soil erosion only, and it erodes away the boundaries of foreground object. So now let me just show you the example. The first thing we need, I'm going to import CV2. So I'm going to use this image, and after this I'm going to import numpy as in p and import matplotlib.pyplot as plt. So after doing this, we're going to create our first image in here, and I want to read this image. So my image name is morph img.png. So after reading of the image, we as in the documentation, if you see that it needs 2 inputs. One is our original image, and second one is called structuring element or kernel. Now we need to create our kernel, so it's basically 5x5 kernel example. So kernel, and this is np.ones. We're going to use 5x5 and np.uint8. So after creating of this, we are going to just create our erosion cv2.erode, and we are going to add our image in here, our kernel in here, and also we need to add the iteration, so iteration to 0. Now if you see the documentation for the erosion, you can see that the kernel slides through the image as through the image, and a pixel in the original image either is 1 or 0. So if it's 1 or 0, it will be considered 1 only if all the pixel under the kernel is 1. Otherwise it will be 0. So now in here we are going to use the iterations 0. So after this, now let me just create titles in here, and original image, and this is erosion, and also images, so our image and also our erosion. So after this, now we are going to just create for I in range of 2 and plt.subplot. Now in here you need to specify the number of columns, number of rows, So we are going to just use 2 by 2, and also this is the position of the image, I plus 1. Now we can just say plt.m show. We are going to show images I, plt.title, and we are going to just use titles and I. So after this, now I don't want the x text and y text for the plt.ytext, and we can just simply say plt.show. Also you can do cv2.wait key 0 and cv2.destroy all windows. Okay, now let me just run this. NumPy has no module uint8, and yeah, this is the problem, uint8. Now you can see that this is our original image and this is the erosion image. So now let's just create the dilation example, and for this I'm going to just in here dilation cv2.dilate. we need to add our image in here, and we need to add the kernel, and this time we need to add the iteration to 1. Now if you see the documentation, so dilation, it's just opposite of erosion, and in here a pixel element is 1 if at least 1 pixel under the kernel is 1, so it increases the white region in the image of the size. Our foreground object increases. Now normally in cases like noise removal, erosion is followed by dilation because erosion removes white noises. Now let's just create okay, now we have created this, and now this time I'm going to use dilation and dilation. Now if you run this, now we can see that this is our original image, and you can see that this is dilation, and it is thicker than the original image. Okay, now let's just talk about another one that's called opening. So now opening is just another name of erosion followed by dilation, and it's useful in removing noises as we explained above. And for this we need to use cv2.morphology.ex. So now let's just, you can see that in this image we have noises, and in after morph open we have this image. Now I have this image, so noises, and now in here I'm going to just say open, and first I need to read my second image. So because, let me just create cv2.mread, and the image name is morph nice.png, and now in here we are going to just use cv2 dot morphology ex. Now in here we need to the first one is we need to add our image, so it's image 2, and after that we are going to add the opposite, so it is cv2 dot morph, so it's morph open, and we are going to just use morph open, and also we need to pass the kernel in here, so kernel. Now and here I'm going to, this time I'm going to just say image 2, and this is the open, and this is also open. Now let me just run this. So now you can see that this is our original image and that we have read it, and you can see after morph open we don't have any noise in here. So another one is that if you see in here, it's closing. Now closing is reverse of opening, dilation followed by erosion, and it's useful in closing small holes inside the foreground object or small black points on the object. So you can see that in this image we have small black points in here, and after morph close we are receiving this result. Now let's just do this, and I have this morph closing, and let me just call it closing. So I'm going to just copy this, paste it in here. Let me change this to closing and morphology X. This time I need to read another image in here, so it is image 3 and cv2.mRead, and the image name is this time, let me just copy this, it is morph closing.png. So now instead of morph open we need to use close, and in here we have added our kernel. The kernel is 5 by 5. So this is our original image, and let me just change this to close, and we want to show image 3, and this is closing. Now let me just run this. So original image, but we are not receiving the same result. So sorry, it's image 3. We need to do this on our image 3, not image 2. Now you can see that this is our original image, and you can see the black holes and the white space of the image. So after morph close, you can see that we don't have these in here. Also, another one is morphological gradient. Now it's the difference between dilation and erosion of an image. So the result will be like this. Now let's just do this in here, and it is gradient, and we are going to just copy our this in here, and I'm going to just use my image 1, and this is morph gradient, and in here we need to add the kernel, original image, gradient, and this is gradient, and let me just run this. Now we can see that this is the original image and this is the gradient. Sorry, in here we need to change this to image 1, and now let me just run this. Now this is our original image and this is the gradient. Now if you see, there's two more. We have top hat and also we have block hat that you can use. Now let's just plot all of them in one frame or in one picture. So now for this, so this is my original image. I have erosion, I have dilation, and I have opening, closing, and gradient. Okay, now in here we are going to just add our dilation, open, so also closing, and gradient. So now we need to change this to a range of 6 because 1 2 3 4 5 we have 1 2 3 4 5 1 2 3 4 5 6. So it's our original image, or also we need to add our erosion in here. So erosion. So now let me change this to 3 by 3, and now let me run this. Now you can see that this is our original image, erosion, dilation, and opening, closing, and gradient. So like this you can work with the morphological operations in OpenCV. In this part we're going to talk about Canny edge detection. So Canny edge detection is a popular edge detection algorithm, and it was developed by John F. Canny in 1986. It is a multi-stage algorithm. It means that there are 5 stages involving for Canny edge detection. We have noise reduction, we have calculation of the gradients, non-maximum suppression, double threshold on all the detected edges, and in the last step analyzing all the edges and their connections. Now there's a function that you can do all the 5 stages just using the cv2.canny function. Now let me just show you. First we need to just import cv2, and also I'm going to import matplotlib.pyplot as plt. After doing of this, we are going to first read our image, so cv2.imread, and for example lino.tif. So after reading of the image, we are going to create our edges in here. cv2.canny, and the first one is the image that we need to add, and after that we need to add the min and max threshold value. So I'm going to add 100 and 200. So now after creating of this, we are going to just say plt.subplot, and we are going to so this is the number of row, columns, and also the position of the image. Now we need to just say plt.show our image, and also I can give a title, so plt.title. This is our so first we're going to show our original image, and plt.xtext. We want the xtext for this. Let me just remove this, but if you want, you can, if you don't want, you can just add that. So we need to just show our second image in here. So this is our edges, and so we can just say edge image, and we can just say plt.show cv2.wait key and cv2.destroy all windows. And now let me just run this. So now we can see that this is our original image, even though there's a messed up in the original image color, but we will convert the BGR to RGB and it will be correct. And you can see that this is the edge image, and you can see that with the Canny detection, these are the edges that we have received. And also you can because right now you can see that it's RGB color and there's a messed up in the colors, so we need to convert our color. And first I'm going to just say image convert. So this is for my original image, cv2.convert color, and we can just add our image in here, and cv2.color underscore RGB to BGR. And let me just do the same process for edges convert. and now we are going to just original image, and this is our ages image. You will see that we are receiving the expected result. So now you can see that now the color is not RGB, now it's BGR, and this is our original image, and this is our age image, and we have ages in here. So like this you can work with Canny age detection in OpenCV. Alright guys, in this video we're going to talk about image pyramid. So image pyramid is one of the best concepts of the image processing. So when we're going to work with images that is high resolution images, sometimes we need to work with images of different resolution of the same image, now like low resolution images. And we create a different resolution of the same image. Now this is called pyramid in OpenCV, or we can say image pyramid refers to the way of representing an image at multiple resolutions. So there are two functions that we can use. We have pair up function, increases the size to double of its original size, and we have pair down function, which decreases the size to half. It means that it decreases the resolution. So now let's just create a simple example on this, and first I'm going to import CV2, and after that I'm going to import matplotlib.pyplot as plt. We need to read our image cv2.mread. We're going to use a bigger resolution image, that's Lena color 512.tif. Now first we're going to just create img level 1 cv2 per down, and we are going to add our image in here, and img level 2 cv2 per down, and we are going to add, we want to do 2-level image resolution. We need to add our image level 1 in here. So now we are going to show this cv2.mShow. So first I'm going to show my original image, and this is image cv2.mShow. This is image level 1, and cv2.mShow, this is image level 2, and at the end we can just say cv2.wait key 0 and cv2.destroy all windows. And now let me just run this. Now you can see that we have different resolutions, the 3 images, that they are in different resolution. Now this is the original image, but now we have, this is the image level 1 and this is the image level 2, and this image, the resolution of this image is not the same as this image, and this is not as the same as this original resolution. Alright guys, in this part we're going to talk about counter detection in OpenCV. So now counters can be explained simply as a curve joining all the continuous points along the boundary, having the same color or intensity. Now the counters are a useful tool for shape analysis and also object detection and recognition. So now let's create our example. First I'm going to just import cv2, and after that I'm going to import numpy as np. So first we need to create an mpt image, so zeros, and we need to give the size 200 and 200, and also the data type. So the data type is np.uint8. So after creating of the image, now we want to get we want to take a part of the image, and we want to make the white color. So we are going to just say 150, so 50 up to 150, 150, and we make the color to 255. So it's the one of the parts from this empty image, and we make the color to 250. So after this we need to just create a threshold in here. So we can use cv2.threshold, and the first one is the image that we need to give. After that we need to give our thresh value, and also we need to give the max value, and that is 250, and the type I'm going to just give 0. We don't need any output destination for this. So after this, now we need to find our contours. So I'm going to just say contours, hierarchy, and we can use cv2.find contours. So this function is used for finding contours. Now so the first thing we need to add our threshold, image threshold in here. So I'm going to just add it in here, and after that we need to add the contour retrieval mode. So we are going to use retrieval underscore 3. So you can see that there are different retrieval, and we are going to use 3. So, and the third one is the approximation method, and we are going to use cv2. So cv2 dot chain underscore approx, and I think there's so you can see we have none, we have simple. We're going to use the simple in here. So after doing this, now we need to convert our color. So we are going to just say color cv2 dot cvt. So color cv2 dot convert color, and we want to convert our image, and we want to convert the gray to BGR. So we're going to say gray to BGR. Now after this we need to draw our contours. So I'm going to just say img cv2 dot draw contours. Now in here you need to first pass your image. So we have used, so our image is color, converted image is name of color, and after that you need to add your contours in here, so that we have created in here. So contours. Also the another value is the index of contours. So I'm going to just give it -1, and after that we need to give the color for the drawing of the contours. So I'm going to just give it blue color. The last one is the thickness. It is 5. So now we can say cv2.mshow image img cv2.weight key and cv2.destroy all windows. So now let me just run this. Okay, now we have an error. So cv2 is not attribute gray to BGR. So we have error in here, and cv2 dot, oh yeah, it's color, and let's check. So now you can see that this is our contours in here, and you can see that this line of code is this part of the image, and the color is 255. It means the color is white, and these are the contours, the drawing contours. You can see the color is blue, and because we have specified in here. Now if I change this to 255. Now it should be a red color. Let me just run this. Now we can see that we have a red color and we have red color counters in here. So like this you can work with counter detection in OpenCV. In this video we're going to talk about circle detection using half circles. So now you can use half circles for circle detection, and also I think we have another one that's called half lines that's used for line detection. So first let's check circle detection, and we are going to use this image for circle detection. We want to detect the outer and also the inner circles in this image. Now first we need to import CV2, and after that import numpy as np. First we need to cv2.mRead. We're going to read our image. Now our image name is planet.jpg. So after this we need to convert this image to gray. So cv2.cvt color planets and cv2.color underscore bgr to gray. So from bgr we are going to convert to gray. So after this now we need to also do median blurring or smoothing the image. So we can use cv2.median blur gray and 5. So after this I've already talked about image softening in the first videos. You can just watch that. So now after this now we need to also convert this image to BGR. So C image, and we can just say CV2. We are going to use this line of code, and in here so this time I'm going to use img, and this time we need to convert from gray to BGR again. So we're going to just use gray to BGR. Now we are going to create our circles in here. So circles, we can use half circles from OpenCV. So half, and after this we can just use circles. Now the first one is we need to pass our image in here, and after that we need to use the method. Now we are going to use half gradient in here. So we can just say cv2 dot half underscore gradient, and after that you need to add the dp, so the density pixels 1, and also we need to add the main distance 120, and for the circle after that we need to add the params 1 and also params 2. So it's the main radius and max radius. So we have main distance, we have main radius, and also max radius. So first we need to add our params. So for the param 1 we are going to give it 30, and or we need to give it 100, and for the param 2 we need to give 30. So after this now we need to give our main radius. So main radius 0, and also max radius to 0. So after creating of the half circle, now we need to just create another circle in here. So np.uint16, so it is the data type that we are going to use, and np.round, and add the circles in here. We're going to round our circle in here. Now we're going to just create for loop. So for I in circles, we need to create two circles, one outer and the another one is the center of the circle or inner circle. So first outer circle, and we can just say cv2.circle. We want to draw circle, so first we want to draw outer circle, and after that we want to draw the inner circle. We want to do this on the planets, and now these are the positions that we have already talked about. Circle, how you can draw circle in OpenCV. I'm going to just write the size and also the radius and the color, and this is the color, and also I think we need to close this in here because this is the I think the radius, and this is the color, and in here we need to add the thickness to 2. And now this is the center of the circle. So let me just copy this and paste this in here, and planets. So we need to just make this 2, and the color we want 255, and let me change the thickness to 5. Okay, now we need to show, so we can just say cv2.mShow circle detection and planets, cv2.wait key, and cv2.destroy all windows. Module numpy is not repeat. We have just it is uint module numpy. Okay, no around. So we have error in here, and it is now it's correct, I think. Yeah, now you can see that this is the center and this is the outer and inner. We have successfully done circle detection in here. Alright guys, in this part we're going to learn how you can do line detection using half lines. So now let's just start our example. We're going to use this image for line detection. So the first thing, we need to import cv2, and after that we need to import numpy as in p. So first you need to read your image, cv2.mRead, and this is my image name. After doing this, you need to convert your image from BGR to gray. So cv2.convert color. We want to convert our image, and it is cv2.color BGR to gray. So after converting of our image to gray, now we need to do Canny edge detection. So we are going to just use cv2.canny. I've already talked about Canny edge detection, and so in here you need to add your gray image, and after that you need to add your threshold 1. So that is mean, and this is mean and max threshold, so 50 and 200. So after this we are going to create our half lines in here. So cv2.half lines. So first half lines. Now in here the first thing we need to add our image. So it is can image So it is not it. Now it's scan image. So also we need to give some more parameters in here. For example, we need to give geometrical representation of the lines. That is RHO and theta, which are usually 1, and also in p dot pi 100 tt divided by 100 tt. So the RHO is the geometrical representation. Now we need to give 1, and for this we can give in p dot pi divided by 100 et, and also we need to give this threshold. It's just an empty array. Okay, now after this, now we need to we are going to use for loop for showing of the lines. So we can use this for line and lines, and here we are going to just get the RHO and theta, and this is the cosine and also sine of the theta, and these are just for drawing of the different lines after detecting of the lines in the image. So after doing this, we need to just because after finding we need to draw lines, now we need to just use cv2 dot line, and we want to draw a line in our image, and these are the positions of the line, and x2 y2, and the color 00255. Also this is the thickness of the line. We can show cv2.mShow line detected, cv2.mShow Canny detection, cv2.wait key 0, and cv2.destroy all windows. So now I'm going to run this. cv2.offlines, the size -1 can be scalar. Now we have a problem in here. Let me just check this. So also I forgot to add 120 in here, so it's the geometrical representation. Now let me just run this. Okay, now we don't have lines in here. So it is because we need to write this out of the loop. So the mShow and also wait key and destroy all windows. Okay, now you can see that we have detected some lines in here, and this is our Canny detection. In this part, we are going to create an example of corner detection with corner arrays. So first we're going to use import cv2, and also we need to import numpy as np. So I'm going to use this image, and we are going to just do corner detection in here in this cheeseboard image. So first we need to just load or read our image. So it is board.png. Now we need to convert this color to gray, so cvt color. We need to add our image and also cv2 dot color underscore bgr to gray. And after converting, we need to convert this gray image color to float 32. So we can just say np float 32, and we need to add gray in here. So after this, we need to use our cv2 dot corner Harris. Now, so the first one is we need to give some parameters in here. We need to give the image the block size. So the block size, it is the size of the neighborhood considered for corner detection. We need to add the k size and also the k. So the k is the Harris detector free parameter in the equation. So now in here the image is gray, and after that I'm going to just add the block size, k size, and also the k, so 0.04. And after that I'm going to just say img. So I need to just make this, so dst or distance is greater than 0.01. After that I'm going to multiply this with the max of that, dst dot max, and after that we need to assign a color to this, and I'm going to assign red color. Now we can just say cv2 dot mshow weight key 0 and cv2 dot destroy all windows. So I think before running we have error in here. Let me just first run this. We don't have an error, but there's no let me just check this, that where's the problem is greater than times. So you can see that the statement says I think the the error is in here, and now now you can see that this is the corners that we have in here, and these are the corners. So like this you can use corner Harris detection.